can you solve for all values of n satisfies this equation? N raised to 6 minus n cubed equals 2. You can pause this video if you want to give this problem a try. And now, let's answer this question together. So, our goal is to solve for all values of n given this equation n raised to 6 minus n cubed equals 2. So technically speaking, we have 6 possible values for n. And I got these 6 values. We have 2 real numbers and 4 complex numbers. Now the question is, how do we get these solutions? So here's my solution. Alright, first thing to do is to notice this n raised to 6. This can be written as n cubed raised to the power of 2. Now, what we're going to do here is to equate this to 0 or subtract 2 on both sides. Now, this negative n cubed can be written as negative 2n cubed plus n cubed. So we can replace negative n cubed by negative 2n cubed plus n cubed. Now, what is the purpose of doing this? Now, take note, on the first two terms, we can factor out n cubed. And this looks something like this. If we factor out n cubed, we have n cubed multiplied by n cubed minus 2. Again, if we distribute n cubed to n cubed minus 2, this will bring back to n cubed quantity squared minus 2n cubed. By the way, let's proceed to its factored form. Now, take note of this term also, n cubed minus 2. So we have common term. Now we can factor out n cubed minus 2 like this. This will give us n cubed minus 2 multiplied by n cubed plus 1 equals to 0. Now, since it is equal to 0, we can say that at least one of them must be equal to 0. So we can say that n cubed minus 2 equals to 0 or n cubed plus 1 equals to 0. Now, at this point, we will use a lot of identities. The first one is the difference of two cubes. It says that x cubed minus y cubed must be equal to x minus y multiplied by x squared plus xy plus y squared. Also, the sum of two cubes, and it says that x cubed plus y cubed can be factored as x plus y multiplied by x cubed minus xy plus y squared. Now, n cubed minus 2 equals to 0. These 2 can be written as cube root of 2 raised to the power of 3. So now we have x cubed minus y cubed form. By the way, on the other side, on the other equation, n cubed plus 1 can be written as n cubed plus 1 cubed. And on the second case, we will use the second identity. It says that x cubed plus y cubed. Alright, let's first consider the first case. We have n cubed minus cube root of 2 raised to the power of 3. Now we will use the first identity. So this can be factored as follows. So we have n minus cube root of 2. So again, x represented by n, while this y represented by cube root of 2. So we have n minus cube root of 2 multiplied by n squared plus n times cube root of 2 plus cube root of 4, or cube root of 2 raised to the power of 2. Now, since it is equal to 0, so at least one of them must be equal to 0. So we can say that n minus cube root of 2 equal to 0, or n squared plus n times cube root of 2 plus cube root of 4 equals to 0. Now, on the first equation, we can definitely get the value of n. If we add cube root of 2 on both sides, we get that n equals cube root of 2. So we have the first value for n. Now, how about in this equation? We will use quadratic formula. We have negative b plus or minus square root of b squared minus 4ac all over 2a. Now, in this equation, in this quadratic equation, the value of a is the coefficient of n squared, which is 1. So we can replace all a with 1. Now, the coefficient of n is cube root of 2. This represents the value of b. So we can replace this b as cube root of 2. And the value of c is the constant, which is cube root of 4. Now, let's simplify. Cube root of 2 raised to the power of 2. This will give us cube root of 4. Now, we have cube root of 4 minus 4 times cube root of 4. we can simplify this as negative 3 times cube root of 4. Now, since the radicand is a negative, so we can factor out square root of negative 1. So this is just I. Now, let's simplify the numbers inside the radical sign. So this 3 can be written as cube root of 27. And cube root of 27 times cube root of 4, this will give us cube root of 108. And square root of cube root of 108 can be written as 6 root of 108. Now at this point, we found two complex solutions for n. We have negative cube root of 2 plus or minus I multiplied by the 6th root of 108 all over 2. Now let's proceed to this second case, wherein we have n cubed plus 1 cubed equals to 0. Again, using the second identity, we can factor the left-hand side as follows. So this x represents n, and this y represents 1. So n cubed 1 cubed can be factored as follows. We have n plus 1 multiplied by n squared minus n plus 1. Now, since it is equal to 0, so we can say that at least one of them must be equal to 0. Now, on the first equation, n plus 1 equals to 0, we can easily get the value of n as negative 1. So, we found another values for n, and this one is a real number. Now, we have n squared minus n plus 1 equals to 0. Again, we will use quadratic formula to solve for the value of n. Again, this a represents the coefficient of n squared. This is just 1, so we can replace all a with 1. Next, this b is negative 1, the coefficient of n. So we can replace all b with negative 1. And the value of c is 1, which is the constant term. Now, let's simplify. Negative of negative 1, this is just 1. Negative 1 squared is just 1 also. And 1 minus 4 is just negative 3. So again, the radicand is a negative, so we can factor out negative 1, and this is just I. Now, this is in its simplest form. Therefore, we found another two complex solutions for n. We have 1 plus or minus I times square root of 3 all over 2. Therefore, we found all possible values for n given this equation, n raised to 6 minus n cubed equals 2. We found two real solutions, and we found four complex solutions. And as always, we are done.